Hey students, it's Mrs. Orth. Welcome back. We're doing lesson number 2 today from Polar Steam. Today's song is called Baby Pictures of the Universe. First of all, you're going to hear from Dr. Amy Lowitz, and she's going to tell you more about the South Pole Telescope and the way that it takes baby pictures of the universe and the cosmic microwave background. And then we're going to sing the song, and hopefully you can also play it on the boom whackers.
My name's Amy Lowitz, and I'm standing in front of a picture of the South Pole Telescope. I'm headed there pretty soon to work on the South Pole Telescope, so let me tell you a little bit about it. The SPT, which is what we call the South Pole Telescope for short, is a microwave telescope, which means it looks at light that isn't part of the visible spectrum of light that your eyes can see, but instead is part of the microwave spectrum of light that your eyes can't see, but we can make specialized cameras that can see that light, and we can use that to learn cool new things about the universe. I'm headed there in a couple of months, and I work on another related project called the EHT, or Event Horizon Telescope. So for 2 weeks a year, we borrow a bunch of microwave telescopes all across the globe, including the South Pole Telescope, and we point them all at black holes so that we can take a picture of those black holes using all the telescopes all together.
Baby, baby, pictures of the universe. Baby, baby, pictures of the universe. Light from the Big Bang, 14 billion years ago, captured by our telescope, the cosmic microwave background. Baby, baby, pictures of the universe. Baby, baby, pictures of the universe. Pictures of the universe. Of the universe.
Hi Amy, I am at my school at Challenge Prep Academy, and here are two of my students, Layla and Brennan. And Layla has a question for you.
Can you tell us more about microwave telescopes?
So she wants to know about that. And Brennan, you got any questions you want to ask? Okay, they're a little shy. All right, we hope you're having a good day. Bye.
Hi, Layla and Brennan and Mrs. Orth. Thanks for sending me your message. So you asked about microwave telescopes. So I'll talk about specifically the ones at the South Pole. So there's actually 3 microwave telescopes at the South Pole. One of them is the South Pole Telescope, which hopefully you can see in that picture behind me there. And there's also another microwave telescope called BICEP 3 and another one called BICEP Array. And all 3 of them are microwave telescopes that mostly study the cosmic microwave background, or CMB for short. So the CMB is kind of like a heat echo from the Big Bang. So it formed about 380,000 years after the Big Bang, which was about 13.8 billion years ago. That's billion with a B. And so when we take pictures of the CMB with our microwave telescopes, we're basically taking like baby pictures of the universe, or seeing what the universe looked like really, really early in the history of the universe. And so we can do all sorts of things with that information. So at this time, 380,000 years after the Big Bang, the galaxies and stars and planets and all of the large-scale structure that we see in the universe today when we look at the sky, none of that stuff had formed yet. This was much earlier. Everything was sort of this hot, dense, lumpy soup. And so when we take pictures of the CMB, we're taking basically pictures of just lumps and bumps. But when we look at those lumps and bumps, we can do statistics on the lumps and bumps and learn things about what happened even earlier in the universe at times that we can't take pictures of. So we can figure out things like, what was the universe like a tiny fraction of a second after the Big Bang? at a time when we can't directly take a picture. The other thing we can do when we do statistics on those lumps and bumps is actually extrapolate to later in time. So if we take the CMB, if we take that picture as like the starting point, and we look at what the universe looks like today, we can ask the question, what has to be true about the universe to get from point A, what the CMB looks like, to point B, what the universe looks like today? So we can ask questions like, how strong does gravity need to be? How much matter and dark energy need to be in the universe in order to get from point A to point B? And all sorts of questions about how the universe works like that. So that's what the microwave telescopes at the South Pole spend most of their time doing.
Thanks so much for paying attention to today's lesson. I hope that you enjoyed learning something new about Antarctica and the South Pole. And I also hope that you have a song in your heart and you sing about Amy's in Antarctica, or baby pictures of the universe, or about the Event Horizon Telescope. Continue to learn more, see what you can find out from books, from online articles, or from YouTube. Remember, music matters, and so do you. See you next time.